Hi, I'm Stefan Lenz, Application Scientist at Chemical Computing Group. Today we will look at the Capture feature in Mo. The Capture button can be used to capture design ideas and track ligand properties in Affinity, efficiently evaluate designs, communicate ideas with colleagues, and create presentations. So let's get started.
In today's exercise, I'll use Capture to document a structure-based drug design workflow. I'll start by opening the file that we're going to be working on today, which is a prepared structure of EGFR kinase bound to a ligand called Tarceva. Next, I'll use Site View to isolate the ligand in the binding pocket, and I'll improve our visibility by hiding the ribbons and coloring the ligand something differently. Now, as part of our SBDD workflow, I'd like to understand where to make ligand modifications and what types of modifications might be optimal. So I'll use an interaction surface to help me understand the where. And interaction surfaces tell us about the steric fit of the ligand. Where we have atoms touching the surface, this indicates an optimal steric fit. Protruding atoms indicate a possible clash. And where we have open space, this indicates that we have steric availability, offering an opportunity to optimize the ligand design by placing heavy atoms along the edge of the surface. And we have such an opportunity around this aniline. So I'd like to document this finding in a database which I can share with my colleagues. I'll start by creating the database. And I'm capturing the current model as well as all of the graphical objects. So I'll title this Steric Availability and click OK. And as I do that, our view is added to a list together with the title and the date that it was created. I'll attach it to the main Mo window, which will allow me to review, add, and edit my ideas efficiently. Next, I'll use electrostatic maps to help me understand what types of functional groups might be best. I'll start by hiding the interaction surface and generating that electrostatic map. These maps show us hotspots calculated from the receptor atoms only. They guide the placement of ligand atoms and tell us what type of functional group might be suitable for each location. In the main Mo window, we have white, red, and blue hotspots corresponding to hydrophobic, hydrogen bond acceptor, and hydrogen bond donor hotspots. If we focus in on aniline, we can see that we have two unoccupied donor hotspots above the phenyl ring, and we also have a hydrogen bond acceptor and a hydrophobic hotspot near the acetylene group. So I'll add a label to one of the aspartates giving rise to an unoccupied donor hotspot. I'll start by adding the residue label and perhaps emphasize that this is a donor opportunity. Add a background fill, and I'll just move it off to the side so it's not in our way. I'll add this to our database, again titling our view Donor Opportunity. One thing I forgot to do was to capture the ligand properties, including the affinity, to establish the baseline of our starting ligand. So I'll add in the ligand properties, and I'll minimize to capture the strain, solvation, and the binding affinity. And rather than create a new view in our database, I'll edit our existing view and choose to overwrite it with our current system. And with that, I'm ready to start modifying my ligand. So I'll start by showing the hydrogen atoms of my ligand, and I'll attach the builder to the left-hand side of the main Mo window. And the builder complements the system manager and capture to create an SBDD console. So let's add a hydroxyl group to satisfy one of these unoccupied donor hotspots. So I'll substitute this hydrogen with a hydroxyl group and click Minimize. And as I minimize, we can see that we're actually forming a new hydrogen bond between that OH and aspartate 831 that we just labeled. So I'll center that in my view, and I'll add this to my database, this time calling it an OH modification. Next, let's focus on the hydrophobic and acceptor hotspots near the acetylene group. I could continue building from this point, but in order to compare the two designs, let's return to our starting point. And I'll zoom in on that acetylene group. So we have to think about an alternative design that can satisfy both the hydrophobic and the acceptor hotspots. And one design that comes to mind is a trifluoromethyl group. So I'll start by deleting the acetylene group and adding in a methyl group. and I'll replace the hydrogens with fluorine atoms. And as I minimize the system, we can see that we're actually forming a new interaction with the hinge gatekeeper. So I'd like to capture this idea in my database. Perhaps this time we'll title it CF3 modification. And with that, that brings us to the end of today's session. So today we saw how to capture a storyboard of our design ideas and affinities in a sortable and shareable database, allowing for easy comparisons of different design suggestions. In this case, we can see that the hydroxyl shows a slightly improved affinity prediction over the native ligand, as well as the CF3 modification. So I hope you've learned a lot today. If you have any questions, please do reach out to me at support@chemcomp.com.